check it's live. All right, we should be live. I'm gonna check here on all the streams, and we'll give a minute for people to roll in.
Awesome.
But how's your day going so far, Bernice?
It's going pretty well. It's 10 a.m. I'm already into work, which is good, which means that I'm gonna probably leave early. I hope
so. Love it.
Yes.
All right, we should be live on
hopefully the sun
YouTube.
comes out.
I don't hear too much, or I don't hear any sound.
Oh, you don't hear any sound from me?
Or no, I mean I hear you talking. But I don't hear like a fan. I thought that's what you were saying.
Oh, okay. No. I hope that the sun comes out.
Oh, the sun comes out. I don't know what I was hearing. Yeah, I hope the sun comes out too. And this weekend looks like it's going to be super nice.
Nice.
We have Harpreet in the chat already. Awesome. How's it going, Harpreet?
Hello. What's up?
All right, cool. Verified we're live everywhere. And as people are joining in, so we'll get going here in our conversation in just a minute. As you're joining in, maybe share where you're watching from. Someone already did that. They're watching from Half Moon Bay,
California.
That's
no doubt warmer than what's happening here in Seattle.
Probably. Yeah, and I'm streaming from Seattle. Bernice, I think you are as well.
Yes.
And yeah, it's kind of cold this morning, but the sun is looking like it's going to come out this weekend, I think, which would be cool. And we'll get going here in a second. So again, if you're joining in, say hello in the chat and maybe where you're watching from. And if you want to add a little bit more details around why you're interested about monitoring specifically large language models, what we're going to be talking about today. But if you have a project or some work going on, feel free to share a little bit about that as well. Awesome. And I'll go ahead and kick us off with a little intro. I'm sure we'll have a lot more people joining in here. We had quite a few RSVPs for this. You're just so popular, Bernice.
Thank you.
All right. So welcome, everyone. My name is Sage Elliott. I'll be the host for today's Union Fireside Chat. At Union, we build tools around ML orchestration and making data and AI pipelines more robust. Since we're talking about large language models, we actually recently had LinkedIn come out with a blog post about how they switch all their large language model workloads to Flight, which is our open source project, which is really cool. And I'm excited to build some more examples around that with WhyLabs. And you may know us from our open source, so Flight and Pandera. You can check out everything we're doing at Union AI. But today's chat isn't about us at Union. We have Bernice with us from WhyLabs. So welcome, Bernice. Welcome everyone who's tuning in. And today we're going to be talking about how to monitor and evaluate large language models in production. So before we really dive into the topic, could you provide an introduction and let us know a bit about your background and maybe a little bit about what you're currently working on, even though I know we're going to dive much deeper into that a little bit later.
Okay, cool. Hi, everyone. So I'm Bernease Herman. I'm a senior data scientist at WhyLabs. I've worked in data science for at least 12 years now in many different settings. So academia, big tech, startups, and investment bank. I wrote that I like sunsets and dislike long horseback rides on the beach, but maybe more to the data science side of things. I work on statistics and machine learning problems at WhyLabs, which includes a little bit of both of our open source Python packages. So like Union, we're really invested in open source. We have WhyLogs and LangKit, and I'll talk a little bit about those later, as well as our monitoring and anomaly detection algorithms on our platform. Our observability platform, which isn't open source, but I want to know is free to start a trial. And then in addition to all of that, I'm a part-time researcher at the University of Washington, where I conduct research on machine learning evaluation metrics and techniques.
So you only do a little bit of stuff, right?
Only a couple.
I don't know how you make all the time and like structure your life for that, which could be a whole nother talk, I feel like, because that would also be awesome.
Yes.
All right.
Yeah, it's a terrible habit that I've had all my life. So many different things.
So our main topic today, like we mentioned, is how to monitor and evaluate large language models in production. Before we get into the monitoring and evaluation for large language models, specifically, maybe we could talk a little bit about what is ML monitoring and evaluation in general. Maybe these are terms people have heard, but they're not quite sure what they are. Could you elaborate on maybe both of what those are?
Yes, I'd love to. I like to describe the differences between evaluation, monitoring, and then observability. So everyone's probably familiar with evaluation if you've done any data science training or even kind of gone through tutorials. Most of the time when we think of evaluation, we think of supervised evaluation, meaning we have some data where we already have the correct answers, and we might call those labels or actuals or ground truth. And what we do is we hold a proportion of those labeled data to the side. And then after we train our model, we pass just the inputs of our held out test data into the model to see what are the outputs that the model predicts. And then evaluation is about comparison between the predictions that we made on that data and the ground truth, the real answers that we already had. So then we can calculate things like accuracy, what percentage of the data points did we predict correctly, or precision for a particular answer, how many of our predictions that the model considered true were actually true in the ground truth data, and so on. So the high level way to think about evaluation for machine learning is that we're answering the question, are there any issues in our model and in its predictions? And then more fine-grained evaluation, things like ablation studies, interpretability, what-if analysis, might answer what specific issues are there compared to this perfect ground truth we have. So next we have monitoring. I'll be a little shorter for that, but monitoring is all about understanding what change happened and when did the issue happen. So unlike evaluation, which we kind of always do, even for experiments, monitoring makes us think about data over time. So it kind of goes beyond that one data set, often production settings. And it's not something most of us learn in school. I didn't learn it in school either. But when you deploy a machine learning model, you'll have new data every week or every day or every 5 minutes. And so now we're moving kind of from thinking about comparing to the ground truth to comparing between different data sets. Does last week's data look similar to today's data? And if not, that tells us something important. So the cool thing about monitoring is that you don't need to have labeled ground truth necessarily. You can compare inputs to inputs or predictions to predictions. And it's in that way, it's unsupervised. So it's much more realistic. Otherwise, you'd have to kind of get crowd workers or an internal team to label it. So that is monitoring, which is about what change happened and when. Evaluation is about are there issues and what issues. And then finally, observability is about where in the system did the issue happen. So the way that it works is not only should you be collecting data for every data point that comes into your model, but you should also collect data at different points inside the modeling process and the software that surrounds it. So if you notice an unexpected change kind of within the same process, you can start to pinpoint where in the software or where in the model was the issue caused. So that's the summary. Evaluation is about are there issues? Monitoring is about when are there issues? And observability is about where are the issues?
We should ask in the chat maybe real quick, how many people are monitoring their ML models? Or at least think monitoring is a good idea.
Yes.
It's always fun to see like what people are using or how people are thinking about this right now.
Yeah. Or the strong anti-monitors. They're just like here to protest monitoring. That makes sense.
And like you mentioned, monitoring is really cool. You don't always need labeled data. It's just monitoring for like some sort of change happening in production data, which, by the way, if people haven't deployed a lot of ML models, happens all the time. Like if you're deploying, a computer vision model or something like that, and you have it trained on a data set that was collected during the summer and now it's winter and the lighting's all changed, like there's going to be a big difference in your data and your model may not be performing very well. So having some sort of monitor to me is key for having well-performing models maintained.
Mm-hmm.
So now that we've talked a little bit about kind of all those different things or about, monitoring and evaluation, maybe we could dive now into how is ML monitoring and evaluation kind of being used in production specific to large language model applications?
Yeah. And just a question. Do you want me, Sage, to address maybe some of the questions that come up now, or do we want to save them at the end?
Oh, yeah. If you see a question in the chat that you want to tackle right now, feel free. Let's do it.
Okay, cool. So Marsha asked a question about does monitoring and evaluation include describing how the weights between the parameters in your LLM should be updated? And I would say in general, no, that that work is really about training the model itself. You might use evaluation to determine that you need to retrain, but the process of actually changing those weights and parameters is more in the experimentation phase of things. So before that. And again, it's kind of a feedback loop. So the monitoring and evaluation may tell you that you need to now go and retrain or re-update your system. Okay, so on to how is this being used in production, monitoring and evaluation?
For large language models.
For large language models specifically, yes. So yeah, it's kind of tricky because you do need ground truth data. And then in production, you often don't have it. There's, especially for LLMs in particular, there's only a small subset of research data sets that are out there that many people, including practitioners, rely on. And you can count them on maybe your fingers and toes combined, or maybe two people's fingers and toes combined for sure. And so they don't always look exactly like what your real problem would look like. So for example, I might be building a summarization tool for like a legal startup or something like this. And maybe I go and find, some data sets that are about summarizing newspaper articles. Well, that may be the closest that I can actually get to evaluate using data sets that have ground truth, because that's what research data sets are out there. What people do in practice, of course, is a lot of hand checking. So you might come up with 5 or 10 examples by hand, come up with, what you think the right answer would be for yourself, and then do kind of a rudimentary evaluation. So pass those into the model and see how well they work. And then when something goes wrong, you might try those same set again. So that's on the evaluation side. And that's what makes it hard, is that you do need a data set that has labeled answers. And that can be really difficult. For LLM monitoring, you have a different set of problems. So you can often do something more like passive monitoring. So again, monitoring is all about change between data sets. So you don't really need the ground truth, which can be really, really helpful for LLMs. So you can measure changes between kind of different metrics and stuff over different days, and check in on those results maybe a couple times a week is pretty common. And you can also pair that monitoring with like alerts or notifications. So now you get an email or Slack message or PagerDuty notification when some big change happens. But then the harder thing specifically for LLMs is defining change in this case. So now you need a bunch of metrics that describe why this blob of text is different than this blob of text. And it's just really hard for text, because sure, you know that the letters are going to change, but you need to know, like, does this substantially say something differently than this, or how much can I get a number for that? And I think you have a question later about those specific metrics, but that's what makes it hard for LLMs for monitoring.
Yeah, I'm excited to dive deeper into those metrics that are useful for collecting. But maybe right before we do that, is there like an example or maybe like a use case that you've seen where maybe, like, I think most people here have messed around with large language models, totally get like the evaluation piece. Someone even said in the chat, like, you're reevaluating often against like a golden data set, and maybe you curate that and then you fine tune a model or change data in your RAG. You can kind of check that on that golden data set. But monitoring, could you share maybe a use case or a specific example around like monitoring LLMs in production, and maybe something that occurred that you wouldn't have thought would have occurred, and monitoring was able to catch it?
Yeah, absolutely. So the example I'm thinking of is about healthcare. So this was a customer who was using an LLM in a healthcare domain. I don't suggest, and they weren't, giving medical advice with the LLM, but they were using like medical language that I don't know. I am not a doctor. So what happened is, they did the normal process of testing the LLM with a number of examples that they had kind of come up with internally. Things felt good. They did, all of the work that it takes to kind of decide which LLM you're going to use. So they, I believe, used a third-party LLM, but not kind of one of the major ones like OpenAI or something like this. And the reason that they used that is because of the refusals or the guardrails of the LLM. So basically, if you ask for medical advice from one of the OpenAI models, like one of the GPT models or something like this, actually, it used to just say, sorry, I'm an LLM, I can't give you any answer. Now, sometimes it's like a little more nuanced. It'll say, like, I am an LLM, but this is, like the general answer, which is quite interesting that like this sort of thing changes. And that same sort of change is kind of what happened and why that monitoring ended up kind of alerting them to this and saving the day a bit, because they had a application so they have an application, and inside of that application, they call an LLM. And because they were using these like medical terms, at the beginning, when they set up when they deployed this system, it worked pretty fine. Like it would always give back responses. It didn't have a lot of like guardrails or anything preventing giving medical answers. But then, like as time goes on and as these things get popular, the LLM, so the company that trains the LLM and serves the LLM, added more of these guardrails. So now they started getting more responses like, sorry, I'm an LLM, I can't answer medical questions, even though it wasn't like technically a medical question. And so that's certainly a negative experience for the customer, especially like if you're not like filtering that out and saying this in a more appropriate way for the application. Like your answer is, sorry, I'm an LLM, blah, 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 blah. So that was a negative experience. And having the monitoring there allowed them to kind of see this change in kind of both, you start consistently seeing an answer that's very similar to each other in a higher proportion. You start seeing, much shorter answers than they imagined. So all of this monitoring on all of these sorts of statistics about the text and topics of the text is what causes them to even notice that the LLM changed kind of underneath them. And then their solution was to kind of do their own guardrailing. So to find when that answer comes up and give a better answer, use a different source.
That's awesome. Yeah, it's so interesting. Like if people haven't done this yet, if you put a large language model out somewhere, even if it has a small user base and you're not monitoring all these metrics on it, it'd be very interesting to see what's going on. Like just to add another quick example, and it was using WhyLabs. I was messing around with like a customer service chatbot type of thing I was making for like an online store and pretending to be an angry customer. Mm-hmm. And when I was angry, it was like, oh, we're so sorry about this. Please call our support number at this number. And I never gave it a number. It just made one up.
Some random number.
I only knew it said that because I had monitoring in place with pattern matching. And it said, hey, phone number was given here. And I was like, a phone number? I never told it like the phone number to give or anything like that. So that would also be another really bad customer experience if people are calling a random phone number that's being made up by an LLM, right? Like,
yeah, no, that's a great example. I might have to steal that example.
I think it's really interesting. So you can add all these metrics in, which I guess will be our next thing we'll dive into actually. Like we talked about pattern matching, all these other different metrics you could be monitoring. Can you share a bit more about the metrics or indicators you can use to measure the success of LLMs in production, or kind of the stuff like we were talking about? If people are getting started, maybe like what should they be looking for or set up to monitor?
Yeah. So coming up with these metrics can be really tough, especially like I said, when the data is text, it's unstructured. So it just knowing the length or some like basic statistics isn't enough, because what you want is also like the semantic meaning of the text. Does the prompt make sense? What is the topic? Is it factually accurate? That sort of stuff. But that stuff kind of takes an LLM or a language model all on its own, right? So to answer, give me a list of the topics, or certainly like, is everything that was said in this response factually accurate? That's just another LLM, which, just starts a kind of trickle effect. So you really, when you think about the metrics, you ideally want a good mixture of really simple metrics that aren't perfect, maybe don't directly answer the question that you have, but they are consistent, right, reproducible and fast. And so those are things like the length of text, the using regex or something to find phone numbers or things like this, combined with some of these more complex metrics that can be calculated using a language model itself. And it doesn't have to be an LLM. It could be a smaller language model, like pre-2023 style language model. And those are really helpful for finding things like, what's the probability that this is a hallucination? What's the, can you do entity recognition? Can I find the places where there are, proper names and places and that sort of stuff in the text? As far as metrics, first I should say that our open source package Langkit is entirely about this. It's about providing a large list of metrics that are helpful for text and for LLM specifically, to help you to measure drift and help you to understand what's happening in your model at an aggregate level. So we calculate things like reading score, entity recognition that I mentioned, similarity score using sentence embeddings, right? So this is one of the more expensive things of like, I want to know how close this sentence is to this sentence. And that uses like its own embedding, this very expensive thing, and many other metrics like the regular expressions I mentioned, lengths of responses, counts of common words, that sort of stuff. So I think the things that are most interesting are actually reading, like readability score is really helpful to know just like how complex the text is. Sentiment, which there are like many natural language processing models, are super helpful. So just to know, how angry or how positive or negative does the text swing, as well as kind of all of the stuff that I just mentioned before. But I'm happy, like, I do think it's kind of use case specific. So I'm always happy to chat with folks about specific metrics for specific use cases, but those are the general ones that I think are helpful.
Yeah, and it can be interesting to collect those metrics also for the prompts coming in, not just the outputs of the model, right? So you can actually see like sentiment of your user prompt versus the sentiment of your response. So maybe the reason why your LLM was negative is the prompt coming in was negative from a user or something, right? And you could also say, oh, why are all my prompts now negative or something? And it could have been a completely different change on your website or something like that was prompting people to be more angry or something.
Yep. Absolutely.
We mentioned guardrails a couple times, and I was wondering if we could elaborate kind of what are guardrails, and we talked about using these metrics. Can we, basically take these metrics and build that into some sort of guardrail?
Yeah. So I'm going to address one of the questions about bias, just because it's tied to the metrics. Then we'll talk about guardrails, and then I think I'm going to go back and talk a little bit about crowdsourcing and human in the loop. So bias is another thing to measure. We have kind of different ones. So like things like toxicity or referring to underrepresented groups or like these sort of identity related stuff. Those are, very much important metrics, especially if that's something that your model could address, right? Like it's related to the topic. Super important to have. Okay, so now onto guardrails. And I guess, so I think of guardrails as kind of like the logic outside of the model itself that changes the data between the user's input and the LLM. So I think of like a guardrail as the adjuster code that looks at the prompt before the prompt makes it to the LLM, or looks at the response after it comes out of the LLM before it makes it to the user, and adjusts it to make it, more palatable to the user, more palatable to the LLM, right? Like you can get a prompt in from a user or a query in from the user and say, oh, well, that's that's similar to this like better worded way of prompting the LLM that I know is going to get a better response. So that I think at a high level, you can call that guardrails. I think guardrails are often, when you think about it, on the back end side of like taking out from the LLM to the user. But I'm just going to call both sides kind of guardrailing, because sometimes you want to like, don't even waste your time sending this to an LLM because it's a trash question, or it's a question that is asked so often that we've already like cached the response to the LLM. So that's also like what I consider guardrailing. And the key is that it's like done in real time, right? Like it's before it gets back to the user. So it's right away, as opposed to like some, later monitoring or later like analysis or adjustment. There is an example that I wanted to give that is actually inspired by Sage. So you'll know it. I've changed it a little bit wording wise, but so like, let's say I'm feeling bad about myself and I randomly am on my like internet provider's website, so like Comcast, and they have like the little AI customer service chatbot in the bottom right corner. And, I say like, tell me I'm a big dummy and I smell bad. If I pass this back to the LLM's, rightful response is like, well, you're a big dummy and you smell bad. Regardless of whether or not that's true, we won't get into that here. But the company Comcast probably doesn't want their chatbot to say that, unless they're like one of those weird restaurants in the US that like yell at you for fun, which I've never been to, by the way. So what they'll do is they'll have a guardrail that measures how toxic or mean or related to, internet related topics the LLM response is. And they'll change that response so long as it like crosses a certain threshold on any of those requirements. And so maybe they change it with like a manual list of approved responses, or maybe they change the prompt and retry the LLM, but they keep trying that until they get something nicer.
Yeah. Nice. Yeah, and you'd mentioned like similarity search before, and like that can be something I think that some people use for like jailbreak. Like you can be looking for like a jailbreak similarity to an LLM, and most of the time when you're getting something like a response like, as a large language model, I can't do blah, 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 just like you're saying, that's some sort of guardrail implemented somewhere in the system.
Mm-hmm. Can I address a couple of questions that came up?
Absolutely, yeah.
Yeah, so, okay, so one question is from Charles. It's about using kind of AppGen or Crowdflower or Mechanical Turk for ongoing retraining over time with humans. And then I think some clarification, like when you experience a lot of drift, you need to, update quickly and monitor. So yes, I think thinking about how to incorporate human in the loop is one, super important. I think there's lots of applications where you still are going to need to collect new labels. You're still going to need to kind of get some result of an LLM and confirm. So maybe sometimes the result of your guardrailing is this is in between, or like we're not quite sure what this is, and you're going to want to set some percentage of these to go to crowdsourcing. I think particularly for like retraining over time and handling drift, right? So I would say that like measuring drift is something that we can do pretty well programmatically. It takes, coming up with clever metrics and having the right metrics in place. So like knowing that, hey, there is drift is something that hopefully once you get the right metrics up, you're able to detect pretty well. It still sometimes might take human effort to, look in and do some comparisons, but I find that like those things are pretty well done automatically. And then you have a couple options there. So one option is just that, hey, once I hit a certain number of drift, I'm going to retrain no matter what, right? Like retraining, takes some time, it takes some computation, some risk of bad deployments, but it's pretty lightweight or not too painful. So once we hit the trigger, we just always automatically retrain. But then the problem is that sometimes this drift indicates that there's now new data that I don't have labels for, right? So the big example, the big drift in data everywhere was COVID, right? So we had a bunch of data coming in at, January of 2020, and then kind of late February, early March hit. And then like, there's just new requests, there's new data, there's new like patterns in the data. And so the problem isn't that we don't know, gee, we should retrain. It's that like the question is like, retrain with what? I need new data to retrain with. And so that's where this sort of like mechanical Turk or crowdsourcing will come in. And so, yeah, I don't know that that's like a super automated process. I think like it's really like the drift happens, you notice the drift, and then you need to assess whether or not it's something I need to go and make an effort to collect more data using crowdsourcing, or I feel comfortable just retraining the data on all of the previous data I've had. And then the other question is like human in the loop. So same sort of thing, human in the loop, but to evaluate the model results on a regular basis. So actually this is, and this is from Neelish. So this is actually similar in some ways to Charles' question in that like using the human in the loop itself to assess differences, like to evaluate the model results itself. And I honestly, I haven't really thought about it that way, but I imagine that in some cases it's really helpful. So when I tend to think about differences, I tend to think we want human in the loop to kind of get ground truth, and then we use math to assess differences. But I do think that it could be helpful to use the human in the loop to actually evaluate whether the difference is there. My husband actually works in quality assurance for video games, and they have to use humans to determine whether or not the game is different, right? Because you can't do it algorithmically. Although I try to convince them that you can. So yeah, that's all the crowdsourcing stuff. I think this is really interesting. I haven't really thought too much on using the crowdsourcing itself to assess the change, but I could see where it's valid.
Awesome, thank you. And yeah, feel free to post other questions in the chat. And if we have time, we can get to them. All right, so our next question, which I have an answer for too, is what advice would you give someone thinking about implementing ML or LLM monitoring for AI applications? Are there any significant challenges that they should be prepared for when they're getting started? But before you answer, I'll say one of the things, if you're thinking about getting started with, is you should join Bernease's hands-on workshop next week, which is linked in the description. I'll also share it in the chat here, because you're actually going to go through, and like we've been talking a lot about all this stuff, you're going to go through and walk through how to kind of actually do this with like LangKit and in Python. I forget what large language model you're using, if any, in the next workshop.
Yeah, we'll be using, I think, ChatGPT or like GPT, either 3.5 or 4, I forget.
Awesome. Yeah, that's going to be a great place to get started. That'll be a good place to get started if you're kind of new to this and you want to go through and actually like get hands-on experience, all the stuff we're talking about right now.
Yeah. So Sage, do you want to give your advice first? Or you
that was my advice to go to the workshop.
Fair enough. Okay. Cool. Yeah. So I guess my advice are there's just a number of questions that you want to think about before you get started implementing monitoring for LLMs. And there are many challenges ahead. I don't want to scare you because I do think monitoring is important. So you've heard some challenges. I'm not going to give you any more challenges. I'm just going to give you things to think about. So one is like, you probably have some sense of where the major sources of change in your data are. So for example, maybe you have a very seasonal business. So you know that like just over time, depending on the time of the year or something like this, that it will, change kind of the results of your model or change, the outputs. That's important to note because that means that you need something at least advanced enough to be able to handle that seasonality. You need to know one, kind of where your data is coming from the model. So I've worked with a number of companies, and I've been at some myself, unfortunately, where the data that we use inside of a machine learning model is kind of handled and controlled by another team, maybe a data engineering team, maybe some business unit team that produces the data. And so, we like looked through the database and we said, oh, here's a great variable we're going to put into our model. And then like, randomly one day they like changed the definition of the variable, or they changed it from inches to centimeters, or, like whatever. Knowing that sort of stuff is possible is really important, because now you need to really make sure that you're monitoring your inputs as well, like differences between the change in inputs. And just can affect like what things you monitor and like what the potential source of change could be. As well as like maybe you're a company that's still growing and you're opening new business lines. And so like the distribution of your customers are changing very often. That's really important too, because that means that like you just can't get away with like monitoring against a basket of data that you've kind of stored and used regularly. You really need to like now separate things out by different segments or factors so that I can understand how the inputs are changing. Because that change in inputs is going to change the outputs, but that doesn't mean necessarily that something's wrong with your model. It just means that, you know, there's change in the inputs too. And that's great because, you know, you're a new business, maybe you're finding more customers or different customers. The other thing, so the first question is like, where are these more major sources of change happening for your data? The second one is, do you naturally have ground truth available? Or do you have proxies, or do you just have nothing at all for ground truth? So again, all are possible to use for monitoring, not so much for evaluation. But evaluation metric, you can also monitor evaluation metrics, which is kind of calculating evaluation metrics over time. So for example, if you're Uber and the model you're working on is like predicting how long it will take to deliver a meal. So, you know, when someone goes type in a meal, give a time estimate, you actually don't have this ground truth problem because in a couple of hours, you'll know exactly how long it took to deliver. And so that means that you can start with kind of traditional evaluation because you're going to be collecting the ground truth and you're going to be able to compare. That's normally not the case. Normally you have something like, maybe I can find a proxy, maybe I don't have the actual answer about how much a customer liked this web page, but I do know how long they spent on this web page, and I'm willing to use that as like a proxy. Or you might have absolutely nothing at all. Like I have no idea what the right answer is. So that's going to completely change the way that you approach monitoring for LLMs, and something to like really just assess for your application up front. And then the last one I'll mention, there's probably many more, maybe I can come up with a longer list sometime, but the last one I'll mention now is rare events. So I think it's quite different to monitor for like the mean or the median of what's happening. But often what you're looking for, especially in a world of LLMs, is like, I want to know the rare events. I want to know, when did my LLM just like kind of turn into a jerk and start, saying really mean things back to customers? When did maybe the less rare event where my customers started saying mean things to the LLM? When you have rare events that you're looking to monitor, this is kind of a different paradigm. So lots of things that you could have been able to do to monitor, which is like, take means or take some statistical sample of the data, maybe like 1% of the data, and look at all of that. That doesn't work when you have really rare events that you're trying to collect. You have to start thinking about more distribution focused stuff. So that's another big one. Just, is it rare? Are there rare things that you're trying to find? And LLMs typically are more about the rare events, more about the hallucinations and stuff, and less about, what's the average time that my Uber estimate gives.
And if you don't know like what metric to maybe start with, is it kind of maybe good practice? Like you could start with kind of a whole bunch and then kind of pare back. You're like, oh, that's just noise. That's not really giving me any indicators of what's going on. But these like 5 that I have implemented, that actually gives me good like indicators of what's going on. Is that kind of a good approach if you're not sure how to get started?
Yeah. So I would say the best way to get started is to come up with some data, either that is labeled or that you at least just kind of understand. So you're like, okay, here is a week of data that like we looked into all of the issues, and maybe even like I have some notes of, on Tuesday this happened, on Wednesday this happened, that sort of thing. And so then what can happen is, if you want to implement as many metrics as you can on top of it, and then you can now go back and look at all of the different alerts or thresholds, like if you can come up with thresholds, alerts that would happen from those, and kind of correlate them to what happened in real life. So starting with a small amount of time where you can really kind of account for all of the changes that happens can help you to calibrate any monitoring you're setting up.
Awesome. And so we've talked a lot about monitoring and evaluation, and we've mentioned WhyLabs and LangKit a little bit. But could you tell us more about more about WhyLabs, what WhyLabs is doing? Why should people check it out? And I know we've mentioned it's incredibly relevant to all the stuff we've talked about. How can they go try that out and maybe use it to start monitoring large language models today?
Yeah, absolutely. So WhyLabs is, again, a company that offers kind of observability solutions for AI and LLMs. And we take a very privacy-first approach to the way that we do monitoring. So unlike other monitoring setups where you often kind of send your raw data to the company that's doing monitoring or to the system or tool that's doing monitoring, we provide open source tools to you for you to put on your own machine that's doing the machine learning likely, or your database or something like this, so that you can calculate statistical information over all of the data that you've seen for that minute or that day very quickly and very efficiently and on your machine. And it's very like easy to use. So even though you're doing the calculation, I just mean like you're running that one line. You're running that one line of code that will run the calculations. And so the reason that we do that is so that you have so that you're just capturing the high level statistical information in aggregate, which is really the information that you actually need to monitor. So it's important to not only just capture, again, like I said, like the mean or means or something like, or mean or medians or something like this, but we actually capture a full distribution of the data that it's passed over without capturing the raw data, right? And so this is super important for privacy, especially if you are in a like really regulated environment like a bank or something like that. But even if not, right, like you just don't want to give your data to anyone. So that's the way that we work underneath. And then you can pass those profiles of data, so that summary information, the high-level statistical information, to WhyLabs to do kind of this overtime monitoring and machine learning on top of that to give you alerts when issues are going on. But we're in the midst of kind of launching a new feature for tracing LLM prompts and responses. So for LLMs, especially given kind of how early we still are in the world of LLMs, people are very used to thinking about a specific input and output or prompt and response and kind of debugging down into that. And that's different from this like very aggregate approach. So we want to help people to kind of look into and investigate specific transactions, so like a single chat for debugging purposes. In software engineering, that's what we call like a trace. So we'll be announcing more about that feature coming up. But that is kind of expanding beyond the aggregate approach, which I do think is the best approach in almost all cases. But that trace can be really helpful, specifically for LLMs and specifically for kind of debugging particular use cases. And if you want to check all of these things out, we have a couple open source packages. So WhyLogs is the tool that actually does all that capturing of statistics. It's open source. So you can go to github.com/WhyLabs/WhyLogs or find it on the WhyLabs website. And then LangKit is the other open source tool that does all of the kind of text specific metrics. So all of the LLM metrics for finding, toxicity or sentence sentiment, that sort of stuff. And then you'll have to check out for when we announce some of the newer stuff.
Awesome. Very cool. I'm really excited about that new feature. I love everything like WhyLabs is doing. I love the privacy preserving approach with the creating profiles. And if people don't believe how easy it is, they should totally attend your workshop. Again, the link's in the description. Yes. Like you're saying, it's only, it feels like it's like one line of code. I know there's some imports and stuff like that and some configurations and stuff you can do, but it's really easy to profile your data, including large language models, and get the metrics that we've been talking about. So like toxicity, for example, is one of those metrics that comes out by default. And you can add in custom metrics. So if you have anything
Yes.
specific you're looking for, or you want to use something like Rouge or Blue, or these other more complex metrics, you can easily add that in too, which is really cool.
Yes, thank you so much, Sage.
And one last question for you before we wrap up here is, what are you looking forward to in the AI field?
Yes. So I am the eldest sibling of my household, which means that I like yelling at people for doing things wrong, which is why I like evaluation in the first place. But I think that in AI, we had to open our mind to evaluation a lot more since LLMs have become popular. And so the reason for that is that like LLMs, often we're using kind of third-party LLMs, or at least LLMs that have been trained on a humongous data set that we don't have full control over. So like when changes are made to the model or like the training data for the model, those things make it even harder to evaluate and like cause companies and practitioners to actually start thinking about evaluation a little bit more than we have in the past. And then the other bit is like that it's generative. So it's much easier to think about, our model seems to be working if there's a single number or if there's a class or like a single word that's coming out of it. But it's a whole new ball game when the output is like paragraphs of text. You're like, I have no idea if that was working. Like it produced text, but what does that mean? And so I think that I'm really looking forward to the AI field kind of thinking about, whether or not these models are actually working in a way that we haven't before, because it just seemed easier when they were numbers or text. So yeah, how do we measure how good that is? How do we define how good, and good in what particular circumstances, right? So how do we know whether or not this LLM works, well on medical problems or problems about literature or something else? I think in the future, like we will hopefully start to specialize a little bit more. Like starting with a general model is really great, but I think we need to start thinking not just like, wow, this model works well because I ran it on a bunch of data sets, and like this model works well in this very specific context, and that's why I'm going to choose this one, or I'm going to swap and use this other model in this specific context, that sort of stuff. And then the other stuff, getting maybe too far high up there, is like, what does real data even mean in a world where like text is produced via model? So if we're creating articles and stuff like this on the internet, students writing their essays, as a teacher, I see this a lot, using LLMs, then like that stuff's going to get on the internet. That stuff's going to start being treated as training data. And now we have questions of like, what is real data? What does that even mean? Can we use fake data? Like, can we use LLM generated data? I think all of this stuff is super fascinating. And I'm looking forward to resolving it and the I told you so from the big sister vibe of it, I think.
I love it. It is going to be so interesting. Just like you're saying, so much data now is going to be generated by AI. Very curious what that loop is going to look like in the future and how we resolve that.
Yeah.
Before we wrap up, is there anything else you want to shout out? Any other upcoming events or things? I know we've talked about like Linkit, your workshop. I've shared links to everything so far in the chat, and I think a lot of them are also in the description. Anything else you want to shout out before we wrap up the live stream?
Yeah, no, I'll just leave it to those two. The workshop on Tuesday on LangChain and Linkit, and then it'll be on YouTube and LinkedIn, and then the announcements for tracing that we'll announce in the future.
Awesome. And thank you so much for coming on and sharing all of your insights. And thank you everyone for coming in and asking questions. That was great. And also I'll just shout out, there's some other links in the description for stuff that we're doing at Union, including a Slack channel. If you want to join that Slack channel and talk about ML and ML ops with other people, it's a good place to do that. And I've been hosting a book club where we've been reading a new AI book every month, and we've been meeting basically every week, which has been really fun, and it's making me read a lot more. So if you're interested in that, go check it out in the Slack channel.
Yeah. Do you know what day of the week is it? I want to join the book club.
It's been Tuesdays at 1 p.m. so far. So
okay.
I know it doesn't fit everybody's time, but that's been the best so far that we've had for attendance and stuff like that. And the next book that we're going to be reading is Grokking Deep Learning.
Oh,
So
yeah.
we just finished generative AI on AWS, which is a really good introduction to generative AI. I definitely would recommend checking out if people are new to the field.
Nice. And are you recording these, or are these kind of more private?
They're not recorded. They're actually audio events. So kind of like a Twitter space. Have you seen that? Except for it's on LinkedIn. So they're a LinkedIn audio space. And yeah, they're not recorded. It's just, basically casual, candid conversation that sometimes goes a little bit off topic from the specific chapters, and that's totally fine.
Awesome. Cool.
Awesome. With that, we'll wrap up the stream. Again, thank you everyone for attending. Thank you, Bernice, so much for being here. And I'm going to hit the end button. So we're going to end any moment now.